Hello friends, how are you? This is Adnan, I'm a mechanical engineer. Today we will talk about the difference between pump NPSHA and NPSHR. So let's move forward. So before we jump into the NPSHA and NPSHR, we should try to understand the importance of positive suction head for a pump. Basically, it's very important to have enough pressure for the pump for the safe operation. Otherwise, it will face cavitation problem. And cavitation is a stage in which your fluid, which is entering into the system in the pump, okay, it will start vaporizing and changing the phase from liquid to the gaseous. So that's why it's not desirable, and it will result into the mechanical as well as the hydraulically problems. So we can understand here from the sketch. Okay, the pump, we have this pump impeller in which we have suction inlet and the discharge as outlet. The fluid is entering to the point A, and in the point B it's going to point B. Point B is basically the pump impeller eye where the fluid is entering. So what happens that once it enter into the impeller eye, the pressure of the fluid, it slightly drops. Normally it's considered as 3%. So once it's dropped, so it should not be dropped in such a way that it become less than the vapor pressure of the fluid. So if it becomes less than that, then what will happen that the bubbles will produce and they will collapse to each other. So in this way that we will experience a cavitation problem. So that's why it's very important to keep this suction pressure always above this vapor pressure. So what is net positive suction head? So we understand what is positive suction head, okay, and net positive suction head. So net positive suction head is defined as the total suction head of pump fluid in feet from the datum elevation less the absolute vapor pressure of the liquid being pumped. So the data, we should understand the datum elevation. Pump has center line is basically it's the datum elevation. So we should have enough suction head, okay, from the at the suction side, okay, and the difference between the suction head and the vapor pressure head is called the, okay, it's called the basically net positive suction head. We can see in its diagram that the suction line is connected with the reservoir, that elevation is above the datum line of the pump. So obviously there is a uh, static head available at the suction side of the pump. So what is NPSHA in equation form? Okay, so it's basically the mm, sum of sum up of HA plus HZ minus HF minus HVP, whereas HA is the absolute pressure on the surface of the liquid. If there is any pressure over exerting over the surface of the liquid which which is in the reservoir, then it will be called HA. HZ, vertical distance between the surface of liquid in the supply tank and center line of pump. As I explained earlier, that vertical difference between this point to the fluid reservoir level, it is called the suction head, static suction head, which is described as Hz. Then Hf, since there will be a friction losses within the piping network, so Hf is called the friction losses, and Hvp is the absolute vapor pressure, which is basically is the minus, taken as the minus from this overall static gain head. So then we come up with the net positive suction head. So as we told you that this is the required, okay, NPSHR uh, is the required pressure that is required to the pump to overcome pressure drop in the suction of the pump and to maintain the pump fluid above its vapor pressure. So the difference between the both NPSHA and NPSHR is called the NPSHR margin, NPSH margin. So as a rule of thumb, the available NPS, which is our system NPSH, should always be higher than the NPSHR, which is required to the pump, because if the system pressure NPSH will not be higher than this NPSHR, which is basically the characteristic of the pump, then it will the pump will start cavitation. So we have this head flow curve in which the NPSHR of the pump is shown in this dotted line, and the system NPSHR is showing on the top of it, which shows that NPSH available at the site is higher than the NPSHR of the pump, till we reach a point where the system NPSH becomes less than the NPSHR. So in this way, above this point, the cavitation problem will start. So what happens that once we do the system design, as a system designer, we should calculate the NPSH A, and then we pass this that NPSH number to the pump manufacturer, and then the pump manufacturer always basically propose his design, which pump has the NPSHR less than the NPSHA. So as a factor of safety, normally there is a NPSH margin of 1 meter is considered. That's mean that the NPSHA should always be higher than 1 meter than the NPSHR. So that was basically the key difference between the NPSHA and NPSHR. Hope it will this concept will be clearly understandable to you. So that's all from my side. So we will meet in next our video. Thank you.